So shooters and reloaders, Fortune Cookie 45LC coming to you from the hot lead zone, and the topic of our video today is calibration. Now calibration is a great word for us shooters and reloaders because we're always dealing with calibers, right? So it sounds like, well, calibers and calibrate. How good is that? But really what calibration means is to set an instrument to a standard and make corrections so the instrument agrees with the standard. So this, of course, is very important for our weighing instruments because we weigh out powder charges, and powder charges are critical. Too much powder and we can have trouble. Too little powder and we have frustration. In years past, when we bought our balance beam scales like you see in the back there, that's an RCBS 510 scale, a balance beam scale. Well, it didn't come with calibration. Basically what happened was we would zero it like you see right there, and it's got to be level, of course. So we zero it and then set the charge, and we go ahead and weigh the charges and have faith and trust that it's accurate. But really, in order to calibrate it, you would put a known weight in here and weigh it, and if it's off zero, then there's a little adjustment that you would make to bring it on zero with a known weight and then the setting of that weight. And if you had that, then you can trust that as being calibrated. Well, we didn't have those in the past. They didn't give us any check weights with that. Now, here you see a Dillon digital, and I bought this when it first came out. I don't know, can't remember when that was, but it was a long time ago, like 35 years or even longer ago. And when I bought this digital scale, it didn't come with check weights either. So basically, you hit the zero and it zeros like you see there, it's zero. And then when you put powder in there, you trust that that's accurate because the factory calibrated it to begin with. But can it lose calibration over time? Any instrument can. And if you were able to calibrate it, like for instance, suppose you put a known weight in here and it wouldn't read that weight. And you had a little adjustment that would let you bring that to zero, that's calibration. Well, we don't have that ability to do that with the scale because it wasn't offered. Now what you see over here is our Hornady automatic powder dispenser. Let's get that in focus. And real quick, you notice that this automatic powder dispenser comes with these check weights. Well, that's used to calibrate. One check weight is a 10-gram check weight. The other one is a 50-gram check weight. Let me show you how you calibrate that. You take the pan off like this. We'll just put it over here. Then you hit the calibration button right here and you press it, and that zeroes it to grams. So it's reading grams now. Then you press the calibration button again and it will ask for the 10-gram check weight. So you put the 10-gram check weight right there. Then you press the calibration button again. Now the unit is calibrating to 10 grams to match that 10-gram weight. Now it's giving us the request for the 50-gram weight because you may very well be measuring some bullets or something that's that heavy. Then you press the calibration button again and it will say pass real quick, which means that it is calibrated. Now, put the pan back on, hit the zero button, and we are now zeroed and calibrated. What that means is this instrument now is calibrated to these check weights. So we have to have faith and trust that the check weights are accurate. Because if this check weight is not 10 grams and this is not 50 grams, then we've calibrated our instrument to an incorrect standard. Now moving over to my other scale. This happens to be an AWS Gemini 20, and it's one of the scales that are available now for very accurate measurement of small amounts of whatever. It could be a powder drug. It could be a diamond with carat weight. It could be penny weights of gold. This scale was made for measuring that out. Now, for grains, it'll measure to the 100th of a grain, which is more accuracy than we need, but why not have that? Now, amazingly, this unit is not that expensive. I think it's like $25. But anyway, that's the power of the chip in there. Because how could something that small, so light, and apparently flimsy, made out of plastic, be so accurate? It's because of the chip. And as you recall, Gordon Moore predicted that computer power would double every year. Now, some would argue that that can't keep going on indefinitely, but at any rate, that's the power of these little chips. And these little chips can do some amazing things, also some very horrendous things, such as guided missiles onto airplanes or even across continents, across oceans, across the world. Put men on the moon, all this kind of thing. Anyway, the way this unit works is you open the little top flap, turn the unit on, and it'll warm up, and it'll read 0, 0. Now that's in grams. We can change that to carats or penny weights or ounces or grams, grains, this kind of thing. But to calibrate it, we take the pan off, then we press the on button and hold it down for a little while, and it'll say calibrate. And you press the button again, and it'll ask for the 10-gram weight. Now it comes with a 10-gram check weight. You put that on there, and you press the on button, then it asks for 20 grams. Now when you put the 10-gram weight on there, it calibrates to the 10, then it asks for 20, so you got to put the other one on so that it can calibrate to 20. And when it does that, then it says pass. And then it reads 20.0, well, 19.99. Well, if you're talking at it, the air movement will give it a little fluctuation since you're measuring to the thousandths of a gram. So it doesn't take much to give it a little error there. So you take these off. And now it's zeroed again. Let's put it on grains. Okay, so we got it back on grains. Now we can actually check these check weights. So here's the one that comes with the AWS. It comes with two of them actually. So we put that on there and you get 154.32. So 154.32 for that check weight. Now here's the second one that comes with the AWS unit. Put that one on there and you get 154.32. Amazing. They're both right on to the 100th of a grain. Now here's the Hornady check weight. We'll put that one on there. Let's settle. 154.38. That's pretty close. Now, of course, we only weigh to the 10th of a grain, so we're looking at to the 100th of a grain. That's pretty close because the other ones, like 3.2, is only off by like 0.06. That's pretty impressive. But now let's go ahead and take these check weights over to the Hornady and see how that one does with these check weights that we can kind of trust because they are in agreement. So notice something very interesting, and that is this check weight, the Hornady one, is at 154.38. Well, if you have a 3.8, you wouldn't want that to be read as 0.3 on a 1/10th display. You would want that to be read as 0.4 because the 3.8 is closer to 0.4 than it is to 0.3, and you don't want to have powder go the wrong way when it comes to a powder charge. And at the same kind of thinking, if you got a 3.2 or a 3.2 talking at it, if you have a 3.2, you would want that to be read as 154.3. And that could easily explain why you have a 1/10 difference from this scale compared to that scale or that scale. And that's why when I said that the Hornady says that that charge is 7.5, and when I come over to this one, it says 7.6, I'm not really upset at that 1/10 difference, because this one's weighing at closer to 0.6 and that one's weighing closer to 0.5. So it all makes sense and it's all good. We can certainly be happy with these because the calibration factors are in play and it's all okay.